Okay. Number 1, a cart with a mass of 45 kilograms is being pulled to the right with a force of 250 newtons, giving it an acceleration of 1.3 meters per second squared. The wheels of the cart are locked and that the cart must be dragged. That means it's going to be kinetic friction rather than sliding, or rather than rolling friction. Find the force of friction acting on the cart, and find the normal force, and find the coefficient of friction. So we have a lot to do. I'm going to go ahead and take my first step, which will be to draw a free body diagram. I'd like to do this pen instead of highlighter though. Fg going down. Gravity is always acting. Fn going up because it's sliding across a surface. Then we have an applied force that tells us of 250 newtons. And a frictional force that's going to be smaller because it's accelerating to the right. And we are looking for the frictional force, we're looking for the normal force, and we're looking for the coefficient of friction. We're given the mass to be 45 kilograms. We're given the force to the right to be 250 newtons. And the acceleration to be 1.3 meters per second squared. All right, so my next step, I've drawn my free body diagram. I made a little list of my information, including my unknown, and I just put question marks next to the other two unknowns here and here. So 1, 2, 3 questions we need to answer. So first, I'm going to go ahead and find the force of friction acting on the cart. But I know I'm going to be able to do this. What I'm going to do first is I'm going to make my sum of the forces equations. Sum of the forces in the y equation, the y direction, are Fn going up minus Fg going down. And we're going to set that equal to Ma in the y direction. When we have a cart that is rolling to the right across a surface and creating friction, we can say that it's probably going to be not accelerating up or not falling through the surface. So we would say that the acceleration in the y direction would be 0. If this is 0, 0 times m will be 0. I'm also going to make my sum of the forces equation for the x direction. Fa to the right, forces to the right, minus forces to the left. And this one is not equal to 0 because there's an acceleration, and that value is 1.3 meters per second squared. So we can't say that. However, we can solve for friction. We can go ahead and solve for friction. Now, mind your signs here and be a little careful. I'm actually going to add Fk into both sides just to be safe, so I have a positive version of this. I have Fa is equal to max plus Fk, but I am not looking for Fa, I'm looking for Fk. So I'm going to subtract max on both sides. So I have that Fk is equal to Fa minus max, where Fa is 250 minus 45 times 1.3 meters per second squared.